Got to remember how to graph linear inequalities. We did these earlier this year. So now remember, let's do our steps. Step 1. Solve for y. The thing you got to remember here is if you're multiplying or dividing by a negative, what do we have to do if we have an inequality? Multiply or divide by a negative, when you're going to solve for y, you have to flip your inequality. One thing you got to remember when you're going to solve for y. Actually, step 2 is determine if it's a solid or dashed line. Does anybody remember how to do that? My boundary line, is it going to be solid or dashed? Does anybody remember when it's solid and when it's dashed? Solid when it's less than or greater than or equal to. It's equal to, the equal to piece. So greater than or equal to or less than or equal to. It's solid. It's dashed when it's strictly less than or strictly greater than. There's no line underneath. It means it's not equal to. So what that means is the boundary line is not part of the solution if it's dashed. Okay, it has to be everything either above, not including that line, or below, not including that line. If it's equal to, you can include anything on the line as part of the solution. So now you graph your boundary line, just like we did with our other lines. Okay, start with your y-intercept. Start with your y-intercept, and then you use slope to find more points. So graph your boundary line, start with your y-intercept, use your slope to plot more points. Then you have to make sure when I go to draw it, I either got to do solid if it's greater than or equal to or less than or equal to, or dashed if it's greater than or less than. Then you have to shade. So we shade above the line when what? When y is greater than or equal to, doesn't matter. Okay? We shade below the line when y is less than. Now, vertical lines are different. We'll look at what we do for number 2 here, because it's going to be a vertical line. Okay, it's going to be a little different, but that's a little common sense type thing. Alright, so let's go ahead and graph these. So step 1, solve for y. Well, already done. Step 2, solid or dashed. We divided to solve for the one variable we do have, so I divided by 2, so x is less than 3. Okay? So now, what kind of line? If I had x equaled 3, where does x equal 3 at? Well, actually, before I draw the line, I got to figure out, is it solid or dashed? It's going to be dashed because it's less than, not equal to. So x equals 3 where? 1, 2, 3. X equals 3 here. X equals 3 all the way along this line. If you only have one variable, either x or y, if it's just x, it's going to be a vertical line. If it's just y, it's going to be a horizontal line. X is 3 everywhere along this line. Now when I sketch it, I need a dashed line, we just said. Okay, now my shading. Which way am I going to shade this? Well, I want all the x values that are less than 3. So where are all the x values that are less than 3? Now there is no above or below. Okay, it's either right or left. The left of it, right? Because it would be 0, -1, -2, right? All along x. I'm going to shade everything to the left of that line. Okay? So here we solve for y, which I didn't have to do for this one. Actually, you should probably say y, or if there's no y, then you solve for x. Okay, and don't forget to flip your inequality if you're multiplying or dividing by a negative. Okay, then you got to determine if it's solid or dashed. Like this one was solid because it was equal to. This one was dashed because it was just strictly less than, not equal to. Okay, then you have to graph the boundary line. Here I started with my y-intercept at -1, went up 3, right 1, up 3, right 1, up 3, right 1. Ran out of room, so I went down into the left. Down 3, left 1, down 3, left 1. Okay, I drew my boundary line in. Then for shading, this is y is greater than or equal to. So I put my pencil on the line and I said, okay, if it's greater than, all the y values that are greater than something are above it. So all the y values that are greater than this line are above it. I shaded that. And the line it's up. The only time you think left or right is when we're talking about strictly x. Okay? Either do above or below when you have x and y, or just y. This one, there was no y, so I solved for x. It's dashed because it's less than. There's no equal to. Okay? Drew my boundary line in. If it's just x equals, I go to where x is that number, and I go straight up and down. X is 3 here, so I went up and down. I drew the dashed line in. And I want to know, where is x less than 3? All the x values that are less than 3 are left of that line. Okay? That's how we graph those inequalities. All right, a system of linear inequalities is where you have multiple of them. It's like a system of equations. Okay, so this one has 3 different inequalities. So the solution of the system is the shaded, where all the shaded areas overlap. Okay, so the shaded areas are the solutions for all of them. Okay, so like when we did our systems before, is where they intersected. Now it's going to be where the shaded areas intersect, or where the shaded areas overlap. Okay? So we're only going to use the graphing method for this. Okay, because it gives us our whole set. So to solve these graphically, you're going to sketch each line and shade. So remember, get y alone. We just talked about how to do that. Okay, and then the overlap is the solution. So you're going to shade them pretty lightly, and then where those shaded areas overlap, you're going to darken that in because that's going to be your solution. Okay, so don't shade too dark when you're doing this until you find out where the overlapping areas are. Then shade that in darker so we can see what area you're looking for. Now, if there is no overlap, there is no solution. So this usually comes when we have parallel lines. Okay, eventually, lines, if they're not parallel, will intersect. So eventually, you will have some shaded overlap, even if it's not necessarily on the graph. But if they're parallel, okay, and they go in opposite directions, then there's no overlap. You can have parallel lines that have a solution, right? If I go above one and below the other, as long as they're intersecting in between those two parallel lines, then you can have a solution. You'd have no solution when you have parallel lines and you shade in opposite directions, like one above this line and then one below this line. Then they would never intersect. They'd never overlap. Okay? Like I said, let me just sketch that real quick. That would look like I have parallel lines here, and I shade everything above this one, and then I shade everything below this one. That would be no solution. Now, it could have parallel lines that do have a solution. Just because they're parallel doesn't necessarily mean they have no solution. So if I were to shade everything like below this line, and then everything above this line, those would overlap in the middle there, right? So this would be your solution in there. Where those overlap. So this would be the no solution case. This is where parallel lines would have a solution. Okay? Alright, so now these. So sketch that one in blue. So it says solve for y. Well, y is already solved for, but there is no x. So can anybody tell me what kind of line I'm going to have here? Well, it's going to be a horizontal boundary line, right? It's going to be horizontal. Is it going to be solid or dashed? What do we look for? We got the inequality sign. Is it equal to? If it's not equal to, that means it has to be dashed. So now, if it's just y, so I go to where y is equal to 1. Where's y equal to 1? Y is equal to 1 right here, right? Everywhere along this line, we said it's horizontal. Y is always 1 everywhere along this line. We said we needed a dashed line. So when I draw this in, I'm going to draw a dashed line in. Okay? Now I want to lightly shade this in. Okay, so I'm going to shade everything. I want all the y values that are greater than 1. So where is y greater than 1? Above it, right? I'm going to shade everything up here. Okay? Now I'm going to graph the next one. We'll graph that one in a different color. We'll use red. So, again, it's y. There's no x. So this is a horizontal line. Is it solid or dashed? one's solid because it's equal to, right? This equal to makes it solid. So I'm going to go up to say, well, where is y equal to 3? Y is 3 here. Okay, and it's going to be everywhere along that horizontal line because there is no x. So y is always 3 everywhere along here, right? It's a solid line. Now I want to shade that one when all the y values that are what? Less than that, below. I'm going to shade all that in here. Okay, so where do those overlapped areas meet? Well, everywhere where? This is that parallel idea where they do have a solution, right? They're both horizontal lines, so they're both parallel. So my solution is everything in there. I'm going to darken that in. Okay, so that's my solution to that. What questions do we have on that? Alright, now this is a system of 3 inequalities. So I got to do the same thing. I got to graph them. I got to graph all 3. Okay, and then find out where those overlap. So the first one I can go ahead and graph right away. I'll graph this one in blue. So, well, we have an x and a y, so it's not going to be horizontal or vertical. It's going to have some angle to it. Solid or dashed? Be solid. And then, am I going to shade above or below? When all the y values that are what? Less than. The less than is below. The equal to means it's solid. So how do I start graphing this one? Where do I start? So it's solid below. I'm going to start up at a y-intercept of 2. This is my y-intercept. Okay, now what's my slope? M, the number in front of x. Well, if there's nothing there, what number's really there? 1, right? So I think of it as 1 over 1. So it's up 1, right 1, up 1, right 1, 1, right 1. So we need a solid line there. Draw that in. Solid line. We need the shade below. Okay. Now, next one. Before I can do anything with this next one, I got to do something. What am I going to do in the next one? Do I have y by itself? No, I got to do what? Got to get rid of that negative. How do I get rid of that negative? Yeah, it's really a -1, right? I'm going to take and divide everything by -1. What should be happening in your head? I just divided by a negative with an inequality, so I have to make sure to do what? Flip the inequality sign. So y is going to be less than or equal to, this is a 1, so now this is 1 divided by -1 is -1. Negative x, -1x, however you want to think about it. -2 divided by -1 is +2. So, is this line going to be solid or dashed? Solid? Am I going to shade above or below? Below. Okay. Where's my y-intercept? 2. What's my slope? That's -1. So I'm going to go down 1, right 1. Down 1, right 1. Down 1, right 1. Once I run out of room, I can't go down and to the right. I'm going to go what? To the left. Now, the other thing you should probably do is look at it and say, okay, well, I know my slope's negative, so that means my line should be doing what? Going down. I have a negative slope, it should be decreasing, right? And it is. Okay. Now I'm going to get my crayon here, or so I can shade it lightly, and I'm going to shade everything below the line because it's y is less than. So where are all the y values that are less than this line? It's below. So I'm going to put pencil, crayon, whatever on that, and shade below. Now, if I only had 2, this would be my answer. But since I have 3, I need where all 3 of them overlap. Now I'm going to go here, and I'm going to graph this one. How do I graph y is greater than or equal to 0? There's no x in it, right? So what kind of a line is it? Horizontal. Is it going to be solid or dashed? It's what? Equal to, so it's going to be solid. Right? The equal to makes it solid. Am I going to shade above or below? Y is greater than or equal to 0. So greater, the y values that are greater than are up, above. So y is 0 right here. Right here, right here. Y equals 0 is the x-axis. Everywhere, every point on the x-axis, y is 0. Okay, so make a solid line there. I'm going to shade everything above. So where do all those overlap? This little triangle right in here. So there's my solution there. Let's say state the vertices, label the vertices, yep. So the vertices are where all those meet. So this vertex is the point what? Zero comma 2. This vertex is what? 2 comma 0. And this vertex is what? Negative 2 comma 0. So now, if your graph is already kind of, can't get them to show up on there, you might want to just go over here and say the vertices are 0, 2, 2, 0, and negative 2, 0. Right? If you drew yours a little dark and you can't get them to show up, maybe label them off to the side. Alright, so let's try some practice here. Everybody try number 1 right now. Okay, both of these are just have an X and no Y, so they're both vertical lines. Okay, and they're both, this one's greater than, this one's less than, no equal to, so they're both dashed. The top one, I want all the X values that are greater than negative 1. So that would be going to the right. The second one, I want all the X values that are less than 3. So that would be going to the left. So where is X equal to negative 1? That's the blue line. So it went to negative 1 here. X is always -1 everywhere along this vertical line. So I drew a dashed line in there. And I shaded to the right. That's the blue shading over this way. Then X is less than 3. So I went to 3. Drew my vertical line in there. And I want less than. So all the X values that are less than are to the left. So I shaded that way. Okay, and then the overlap is here in the middle. So I darken that in. Okay. There are no vertices here because there are no corners. The solution would be any point in between those two. So any point that has an X value between -1 and 3. Okay? Because it's vertical. They're both going up. Alright, any questions on that? Alright, let's try number 4 right now. So what's the first thing we got to do in both of these? Okay, you have to solve for y. So for this first one here, I have -x plus y is less than -3. So to solve for y, I got to get rid of the x term. So I have to add x. Y, positive y, which is just y, is less than x minus 3. Now remember, if it's just x, it's really a 1 there, right? So to graph this, well, I'm going to determine, is it going to be a solid or a dashed line? It's going to be dashed. Okay. Am I going to shade above or below? Looks like the inequality relates to y. Y is less than. So where are all the y values that are less than something? Below. Right, so I'm going to shade below. To get my boundary line, I start with my y-intercept. What's my y-intercept in this case? -3. So my y-intercept's -3. Now, to get more points, I use the slope. So what's my slope here? 1. So I go up 1, right 1. You always go, it's positive, so I'm going up. You always go to the right. Whether you go up or down, you always go to the right. So it's positive, so I'm going up and to the right. Okay, now, if I run out of room going up and to the right, then I go back here and go what? Down to the left. When I jump on the other side, that's when I can go the opposite. Okay, we said we needed a dashed line. All right. And I want to shade everything below that line, because y is less than. Where are all the y values that are less than? This is the expression for the line, the 1x minus 3. So the y values that are less than that are below. Okay. That. Now, next one. So, how do I solve this one? For y. Add x. Yeah. So it's just y, positive y is just y. It's going to be greater than x plus 4. So do I need a dashed or a solid line? Dashed. It's not equal to, so I need dashed. Okay. Am I going to shade above or below? I want all the y values that are greater than x plus 4, so that's above. To draw my boundary line in, where do I start? 4 on the y-axis, there. My slope is what? 1. So what do I know about these lines? Parallel. Okay. Now my shading, we said we have to shade above. So I put my pencil there and I go above. I want all the y values greater than this line. So it's everything above that line. So where do those two shaded areas overlap? They don't. So what does that mean? No solution. So this is parallel and they're shaded in opposite directions. So that means there's no solution. There is no place where they overlap. Okay? Now, careful with number 5. This first equation's already got y solved for, but it's not usually the way we do it. Right? So for number 5, I always want to read this from the y. So I can rewrite this as y is, what sign is facing towards y? You rewrite it the same way. Y is less than or equal to negative x. If you want to flip the inequality, you got to flip everything, the sign, everything. Flip the inequality sign, not the negative sign. But flip the inequality sign, flip everything over. So y is less than or equal to negative x. So that's already got y solved for. So how am I going to graph this? Dotted or solid, or dashed or solid line? Solid, because it's equal to, right? Where am I going to shade it? Below. Y is less than or equal to. The y values that are less than are below. Okay? So to graph this, how do I start graphing that boundary line? Look for the y-intercept. What's the y-intercept here? 0. If there's nothing there, it's really what? It's an unwritten plus 0. Right? So my y-intercept is at 0. What's my slope? Yeah, if there's a negative there, it's really a negative 1. So that tells me I got to go where? Down 1, right 1. Because my slope's negative, so I got to go down and to the right. So we needed a solid line. We're going to shade that. Which way am I shading it? All the y values that are less than that, so below it. Alright, next one. I gotta do something before I can start graphing this. What do I gotta do first? Okay, it's negative x, so to get rid of negative x, I'm gonna add x. Y is greater than or equal to x, positive x minus 5. So, solid or dashed line? Equal to, so it's going to be solid. Am I going to shade above or below? Above, because I want all the y values that are greater than this line. Y is greater than above. Up. Okay, so where do I start my graph at? The y-intercept, which is negative 5. Okay, now what's my slope? 1, so I go up 1, right, it's positive, so I'm going to go up and to the right. Can't go up and to the right, I'm going to go back here and go down and to the left. Okay, so we needed a solid line. Shading everything above. So, do those overlap? Over here, right? So there's my solution. So I'm going to darken all that in. Shade that in darker so you can make sure to definitely see that that's the intended solution. Okay. All right. So go ahead and try number 6 right now on your own, please. Try number 6. Okay, what do we get for number 6? We have a solution, no solution. What do we got? No solution. These lines should have been parallel. So the first equation, I had to take and divide by 2. So when I divide by 2, I get y is less than negative 5 halves x minus 5. So that's dashed, and I'm shading everything below. So that's this blue line here. Started at negative 5 as my y-intercept, and I went down 5 and right 2. Couldn't go down into the right anymore, so I went up and to the left. Up, left, up, left. I drew a dashed line in there, and then I shaded below, everything below. So put your pencil on the line and go below that. There's everything down there. The second equation, I first had to subtract 5x. So I got 2y is greater than negative 5x minus 2, divided by 2. So I get y is greater than negative 5 halves x minus 1. So that's a dashed line, and I shaded above it because y is greater than that line. So I started at -1, went down 5, right 2. Well, down 5, right 2 would be off the graph. So I went back here and I went up 5, and left 2, up 5, left 2. Drew my dashed line. Now shaded above. Everything above that line, put your pencil on the line, go above, up. There, in that area. So those shaded areas never overlap, so there's no solution. Alright, let's try one with 3 equations now. Alright, go ahead and try number 7. Alright, your graph should look something like this. The first one is a vertical line at -8, and it's solid, and I want all the x values that are greater than that. So x is greater than to the right. So I shaded to the right. The second one is a horizontal line because the only variable is y. So y is -1 down here, and I shaded below because y is less than below. This is solid because it was equal to. Actually, I messed this up. This should have been a dash line. The green one should have been a dash line. It's not equal to. I wrote dash. Alright, so it's a dash line. Y is less than -2x minus 4, so I'm going to shade below the y value less than. The y-intercept is -4. Slope is -2. Down 2, right 1. Down 2, right 1. Can't go down to the right. Up 2, left 1. Okay? So there's that line. And I want to shade below. So everything below that line. So pencil there and shade below. So the overlap between all three of those is in this area here. All right, what questions do we have on that?